Hi, welcome to Unit 9A, Day 2. Today we're going to look at measuring angles and arcs, and we're going to do a little bit of an exploration. Okay? All right, my first prompt here, it says to use a straight edge to draw 2 radii in the circle to the right. So that's what I'm going to do. I'm going to draw 2 radii. And I just have a straight edge. So from the center, I'm going to try to get as center of the center as possible. And I'm going to go this way. And just draw myself a radius. And it says to draw 2, so I'm going to draw one more. I'm going to draw this one over here. Second radius. Okay, so step 1 done. Draw 2 radii in the circle to the right. Next thing I want to do is measure the angle formed by the radii I drew and put it in the picture. So step 2, I'm going to get my protractor and I'm going to measure that angle that I made right here. Okay, so to do that, let me get a pen. All right, I need to line up the center of my protractor with the center of this angle. So I'm just going to line it up, and then I'm going to line up either this out to this 0 or out to this 0 with one of the 2 radii. Okay, so I'm just going to turn it this way and line it up right with the center, and then, oops, right there. And notice it's going to this 0, so that means I'm using the numbers on the inside, because out here this says 180. So I'm using the numbers on this inside arc of numbers. And when I come around, I can see that oh wow, I did really good. I'm right halfway between 100 and 110, so my angle is about 105 degrees. Okay, so this angle right here is 105 degrees. Okay. All right, now we have a little bit of vocabulary. It says an angle whose vertex is at the center of a circle and whose sides are radii. So remember when we drew this one, we did this as a radii, a radius, and this was a radius. Okay, and I know that this is the center of my circle. So I have an angle whose vertex is at the center and the sides are radii. So this is the central angle. Okay, I drew a central angle. What is the measure of the central angle that I drew? The measure of that angle is 105 degrees. Okay. Intercepted arc. The part of the circle between the rays of a central angle is the intercepted arc. And it wants me to highlight the intercepted arc that I created on my picture. So let me get a highlighter, and I'm going to highlight the intercepted arc. So the intercepted arc, that's my vocabulary, is the part of the circle between the rays of the central angle. So if I come out on the radius, that's the ray of the angle. So my intercepted arc is from one to the other. That is my intercepted arc. Okay, so again, my central angle was my angle at the center. This one here is my central angle. I'm going to try to match my colors. Central angle and intercepted arc. Okay, let me label that in my picture as well. So I'm just going to label this. This is my intercepted arc. Right there. Okay, so I've got my 2 radii that are making the central angle and creating and dividing essentially the circle into 2 arcs, ARC, and the intercepted arc is the one in between the 2 radii. Okay. What's kind of neat is intercepted arcs have the same measure as their central angle. So when it says what is the measure of my intercepted arc, it's also going to be 105 degrees. They have the exact same measure. Okay? And again, that's going to be the same if you have a big circle or a small circle. It doesn't matter, because the number of degrees around the arc, no matter the size of your circle, will always be 360 degrees, right? All the way around. Okay? All right, next we're going to look at types of arcs. We have minor arcs, major arcs, and we have semicircles. So it says to number 3, look at the arcs above and take note of their names and compare their measures to their classification. So they're teeny tiny. Let's see if we can zoom in a little bit. All right, so I have this first one here that is called, it's in circle A, right? Circle A, capital A. And I have a minor arc, and I have a GH with a little arc above it. And notice the G is one endpoint, and the H is the other endpoint of that intercepted arc. And then inside, I've got a 71, which means the measure of that arc is 71. So my 71-degree arc is a minor arc. Okay. Here, I have 228 degrees, and I can see my arc that is highlighted is in circle B, and it's a major arc. And notice it took 3 letters to name this one, JLK. Okay. My next one, circle C, is a minor arc, and we're calling it minor arc MN. M is one end, N is the other end, and it's 113 degrees. So it seems like a lot of degrees, but yet it's a minor arc. It's bigger than an obtuse angle, or it's bigger than a right angle, right? So it's obtuse, but yet it's a minor arc, so that's kind of interesting. Here I have a semicircle, PRQ, PRQ, so notice I have P and Q are the endpoints, my outside letters, and then R is on the arc, and it's 180 degrees. Here I have a minor arc that's an obtuse angle, but it's a minor arc, and it's named with arc ST. S is one end, T is the other. And then my last example here, I have a major arc, UVW, and U and W are the ends, V is somewhere on it, and it is 233 degrees. Okay, so let's see if we can look and see some commonalities here. So when I look at number 4, it says the measure of a minor arc must be. So let's look and see what our minor arcs are. My minor arc is here, 71 degrees. Another minor arc is here, 113 degrees. And then another minor arc is here, 153 degrees. So sometimes when we think minor, we think the same kind of as acute, but they're definitely not always acute, right? Because these are definitely bigger than 90. So you can have obtuse central angles and still be a minor arc. But what we might notice is that they are all going to be smaller than half the circle, right? Because it's 360 degrees all the way around. So the measure of a minor arc must be less than 180 degrees. Okay, and it says minor arcs are named by, so let's look at their names. We've got arc GH, we've got arc MN, and we've got arc ST. So they are named by the endpoints of the arc with an arc drawn above. Okay, and normally you do a nice smooth arc. These kind of have little bumps on them, but it's the software we have that is the arc symbol that we get. Okay? All right, when I come over here to number 5, it's talking about a semicircle. The measure of a semicircle, well, I only have one semicircle. That is right here, and we can see its measure is 180 degrees. So the measure of a semicircle must be 180 degrees exactly. Because we know if it's a little bit under, it's going to be a minor arc, right? It has to be exactly 180 degrees. Semicircles are named by, so notice this time I don't just have 2 letters, this time I have 3 letters. Okay, so this time it is the endpoints and a point on the arc. Okay, and it says, do you think order is important and why? Okay, so order is going to be important. It's kind of like with an angle. The point that's on the arc has to be in between the two endpoints when you name it. So order, yes, we're going to say yes, order is important because it tells you where to start and where to stop. We're starting at P, we're passing through through R, and we're ending at Q. So we're starting at P, we're going through R, and we're ending at Q. If my letters were out of order, let's say they were PQR, then that would mean I was starting at P, going through Q, and ending at R. I'd have to go all the way around the long way. Okay? So order is important. It tells you where to stop or start, when to stop, and which direction to go. So it tells you where to start, when to stop, and which direction to go. Because if I just had PQ, yes, I would know PQ would be a semicircle, but I wouldn't know if it's the left side of the semicircle or the right side of the semicircle. So it's important to have that R in between so I know it's the left side. Okay? All right, and then lastly, number 6, we're looking at the measure of a major arc. And the measure of a major arc must be, let's look at my major arcs. I've got 228 degrees. And then here I've got, degrees. And then here I have 233 degrees. So we've got measure of a minor arc is less than 180. A semicircle is exactly 180. The measure of a major arc must be greater than 180. Okay, and it says major arcs are named by, we're going to use the same method. Notice if I look at my major arcs, it's J, L, K. So it tells me where to start, where to end, and which side to go. If I just put JK, it's always going to be, that would be the short side. Okay, adding the L in there tells me I need to go the long way around. Okay, over here when I have UVW, if I just did UW, I would go the short way. But since it says I have to include V, I know I'm going the long way. Okay, so they're named the same as semicircles, and order is important for the same reason. It tells you where to start, where to stop, and which direction to go. So major arcs are named by the same method as semicircles. And yes, order is important. Why? For the same reason. For the same reason. It tells you where to start, it tells you where to stop, and it tells you which direction to go. Alright? In the next video, we're going to look at some more of these where we're actually going to be finding angle measures and we're going to be adding some arcs together. So make sure you come on back for arc addition in the next video. Thanks so much for watching.